All right, welcome back, Algebra 2 people. So we just finished the unit on like all the parent functions and transformations, domain and range, and stuff like that. So for the rest of the year, each individual unit, we're going to be talking about some of those functions in more detail. And the first one of those we're going to talk about is the absolute value function. Now, if you remember from a while back, we know that the absolute value function looks like this. It's a V shape. And we'll talk about the domain and range and all that and some different properties here in just a couple minutes, but just to kind of trigger that kind of memory, that's the function that we're talking about. Also, remember last week we talked about all the different transformations kind of in the general form of, what the A value does, what the B does, HK, and so on. So now for absolute value function, we're going to take that specifically, instead of writing it in general kind of function notation, we're going to actually use what this function is. Now, if you remember, the absolute value function is when you see those two vertical lines. We're going to get into specifically what that means starting tomorrow and start looking at some equations and some uses of the absolute value functions. But today we're just going to be talking about just those transformations. Okay, so if you remember from previously, our A value, that number that's stuck in front of the function, remember that's our vertical stretch or compress, and it's vertically compressed if it's less than 1, and vertically stretched if it's greater than 1. Okay, now remember those can be written as decimals or fractions, and also the negative doesn't matter for compression or stretch. The negative, we'll talk about that in a second. That's when it just gets reflected. But just look at the number itself, less than 1 compressed, greater than 1 stretch. Now, this is the one where a lot of students kind of get just careless on, is if you see an A, it's a fraction, you're like, oh, it's a fraction, it must be a vertical compression. No, remember, if the fraction if it's greater than 1, it is a stretch. So that's still going to be a stretch of 5/3. And then we have the K and the H, right? So the K, remember, that's adding, subtracting outside of the function, and that just does what it kind of looks like it does. So it's a positive K outside, it's going to translate that many units up. If it's a negative K on the outside, it will translate that many units down. And then the H value, remember the H is kind of backwards from what it looks like in the function, because the formula, remember, was minus H. So this is really when H is greater than 0, so it's translating right. If you see X minus H, it's going right. And for the X plus H, that means H is negative, so it's going to the left. Okay, so just remember, in the function, it changes the X value. It's backwards from what the actual H value is. Okay. Referred to this just 1 second ago. Remember, I don't care what the A value is, if it's less than 1, greater than 1, doesn't matter. If it is negative, it is automatically going to reflect over the x-axis. Okay. Also known as being upside down. Okay. Now, for the most part, we are not going to see a B value for these absolute value functions. You might see a reflection across the y-axis once in a while, something like that. But as far as on a test, on any kind of assessments, you aren't going to see any kind of B value. So we're just not going to worry about that a whole lot on these. Okay. So make sure you know those. You should know those even from last unit. And we'll do some practice on those in just 1 second. Some other properties of absolute value functions that you should definitely remember, honestly, from last unit, and maybe a couple of new terms also. So remember the domain, remember, it was all real numbers. That's never going to change. It doesn't matter what's going on transformation-wise. It's always going to be from -infinity to infinity. The range, however, could change. On the parent function, notice it's 0 to infinity with a bracket on the 0 because it touches that point. But notice if it starts shifting up and down, then the vertex is also going to change, right? And the range will change. So like if you had one that's been shifted up 4 units, you see that's the point 0, 4, then that domain, or sorry, the range would be from 4 to infinity, okay? The h value doesn't matter, but the k value can change. Also, it could change with a reflection also. Because if you had a function that looked like this, right, now the range is going to go from negative infinity up to that h value. So just know the range can change depending on what the a and the h values are. Same thing with the vertex. We know the vertex of the parent function is 0, 0. They're at the origin. But again, if h and k are different, if it's going left to right, up, down, that vertex is also going to change. It's going to be exactly hk, in fact. And then the axis of symmetry, if you remember from your middle school days, we know what symmetric means. It basically means it's a mirror image on one side and the other. So notice for the parent function, the axis of symmetry is along the y-axis. Or you could say that's a line x equals 0. And again, it's also going to change with the h value. Okay? And the last few things, it's more kind of just some kind of background. These are it's formed by 2 linear equations. We'll talk about why that is when we get to the definition of an absolute value function tomorrow. But it's basically got a slope of -1, slope of +1 on the right-hand side, and then it goes from decrease to increasing. Again, that's a little bit beyond algebra 2, but I like throwing that in there at that time. So that's really all the notes. Now we've got to talk about, okay, what do the problems look like? So here's 4 problems here. I'm going to do the first one, and then I'll let you guys pause the video, and you can do number 2, 3, and 4 on your own. And then we'll look at a couple other types of questions you can see also. So number 1, parent function is vertically stretched by a factor of 6, translated 1 unit right and 4 units down. So you just kind of list out your values and then use those values to write your function. So vertically stretched by 6, so that means a is 6, easy enough. 1 unit to the right, so h is +1 because it's going to the right, and k 4 down, k is -4. To write the function, I'll call it f of x equals, and again, just remember your format. The a goes in front, and then your vertical line, x minus h on the inside, and then plus, and then whatever k is on the outside. So since h is plus, remember that's going to look backwards. So we have a 6 out front, and then we have x minus 1, and then -4. And that's it. That's your function. Nothing else you got to do. So go ahead and pause the video real fast. I'll scroll down just a hair. Go ahead and pause the video and see if you can do number 2, 3, and 4. And then we'll kind of zip through those answers and do the next kind of questions after that. Okay, so hopefully you got these guys done. So again, reflected over the x-axis, so we know the a is going to be negative, vertically compressed by a factor of 1/3. So that means a is 1/3, but it's also negative since it is a reflection. It kind of doing both things at once. Shifted 5 left, so h is -5. 2 down, k is -2. Write the function. So -1/3, your a goes out front. Remember, if it's going left, it's going to look backwards, so it's x plus 5, and then -2. Number 3, there's only 2 things going on. Vertically stretched and 2 left. So vertically stretched, a is 2, there's no reflection going on. 2 left, so h is -2. There is no k, so it's just 0. So this function would just be 2 absolute value of x plus 2. If you wrote plus 0 on the outside, it's fine, but since it's 0, we don't need to worry about writing it. And then lastly, number 4, try to throw one at you just to see if you remembered it from last unit. Again, you won't see this on the test, but I got reflected over the y-axis, vertically compressed, and then 5 up. So vertically compressed by 2/3, that's just going to be 2/3 is your A. There's no left and right, so H is 0. And K would be plus 5. Okay, so going to back to my function. So 2/3 absolute value of. Now remember, if you remember from the previous unit when we did have some B values, if you remember, if it's going over the y-axis, that means it's the negative sign kind of attached to that x. Okay, so that's what that reflection would look like across the y-axis. And then your plus 5, again, just goes on the outside. Okay, I think those are the kind of the trickier ones to do because you got to kind of write your own function and get all the information out from the verbal description. But once you do a couple times, it's usually okay. Let's look at the next set, and I think these are easier. So now you got the parent function and you're transforming it to 2 absolute value of x minus 1 plus 4. Describe the transformations and write the vertex domain and range. Okay? So again, I'll do this time. I got one more on the next slide. I'll let you do by yourself. So when I say listen, you don't need, I'm not worried about like a complete sentence or something like that. So again, we know this is my A, we know that's my H and that's my K. So I've got a vertical stretch of 2. It's translating or shifting 1 right and 4 up. Remember that H is always going to change signs on you. Now, as far as your vertex, remember, I'm going to give you a hint here. The vertex is always going to be H comma K. So once you know your H and your K, that's going to be your vertex. Okay, so my vertex in this case, remember I'm going right 1, up 4, so it's going to be 1 comma 4. We said a second ago, remember domain is never going to change. It's always going to be that all real numbers, negative infinity to infinity. How about the range? Well, let's talk about this for 1 second. So we talked about it already. It's going to change with the K value. If I were to sketch this thing, so here's my parent function, and if I go right 1 over 4, it's going to be up here somewhere. So it's going to look something like this. Again, just a very rough sketch. So that tells you that your domain, your range starts here at 4 to infinity. So again, it's always going to be based on your K value. But you have to be a little careful if there's a reflection going on also. Okay. So here's the next problem. Again, pause the video for just 1 second and see if you can list the transformations, write vertex, domain, and range, and we'll go through those answers pretty quickly. Okay, so we see the negative out front. We know that's a reflection across the x-axis. It's a vertical compress. And then it's shifting 5 left and 2 down. Now the vertex, remember the vertex is just going to be H and K always. So my vertex, my H is going left is -5 down to -2. Domain is a freebie. always the same thing. Range, again, you got to be careful on this one. Because again, if I were to sketch this graph, left 5 down 2, so down here somewhere, but it's also upside down. So now the range is going to be negative infinity to negative 2, still with a bracket. Okay, see all the k value, that didn't change. Just the order changed because now it's going upside down. Okay. Last couple questions, and these are more kind of on the pre-AP side of things, but I think they're good questions. So if the function absolute value of x minus 4 plus 1 is shifted 3 right and 5 up, what would the new function be, and what would the new vertex be? Well, notice the vertex on the original function here is 4, 1. So if I go 3 right and 5 up, then I'm going to be at 7, 6. So total from the parent function, I move 7 right and 6 up. So now I can write my new function, x minus 7 plus 6. And we could do the new, and we could do the new domain and range, all that good stuff like that, and the axis of symmetry. By the way, don't forget the axis of symmetry is just that h value. So like on this one, on this g of x right here, the axis of symmetry here would be x equals 7. It's always going to be that h value. Last one I'm going to do, and again, in the online world, it's a little harder to ask you guys to graph them by hand, but I think it's a good exercise to do at least once in a while. So again, here's a new function. Look at the transformations. So it's reflection. We're going left 2 and down 1. Okay? That means my vertex is at -2, -1, and my axis of symmetry is at x equals -2. So if I'm going to graph this thing, I'm going to do a dotted line for my axis of symmetry. I'm going to put a point on my vertex right there. And then there's no other vertical stretch or anything else like that going on, but it is upside down. So that means it's going to be going down kind of on that slope of -1 on one side and +1 on the other side. So that's kind of what the graph would look like on that. Okay. That is transformations of absolute value functions. Make sure you know, again, the main thing, A, H, and K, know how to find the vertex, know how to find the new range, domain, always all real numbers. Come to tutoring if you need some help. Until next time, stay safe.